Our objectives for today's lesson are to be able to do heat calculations for various chemical reactions and the phase changes of water. There are three main heat formulas that we're going to be looking at. Those can be found on page 3 of your reference table. Let's take a look at the first heat formula, and that is Q equals mc delta T. If you remember from the endothermic and exothermic reaction notes, Q is equal to heat, and our unit for heat is going to be the joule. M, as usual, stands for mass, and our mass needs to be in grams. C is something that we call the specific heat, and that is defined as the amount of heat needed to raise 1 gram of a substance by 1 degree Celsius. Many values for specific heat for metals can be found on page 1 of your reference table, or a lot of times that's something that you will be solving for. The unit for specific heat is joules over grams degrees Celsius. And that's just another weird unit that we use for various constants to help all the other units work out. And then the last part is delta T. Anytime you see a delta in front of anything, that means change. So delta T is the change in temperature. And so to calculate that, you always want to do your final temperature minus the initial temperature. And our temperatures for these calculations need to be in degrees Celsius. Let's take a look at an example. So our first example says how much heat is needed to raise 250 grams of iron by 55 degrees Celsius. Okay, so the first thing we want to do is figure out which formula to use. In this case, we've only learned one formula, so we know that we're going to use Q equals mc delta T. Okay, let's start filling in what we know. Right, Q is heat. That's what they're asking us for, so we'll leave that alone. M is going to be mass. Our mass that they gave us is 250 grams, so we can plug that in. The next thing we're going to look at is C, the specific heat. So if we look on our reference table on page 1, we can find iron, and we see that iron has a specific heat of 0.449. So we can plug that in for C. And then finally, our delta T this time, instead of giving us two temperatures that we need to subtract, they went ahead and did the subtraction for us, telling us that it raised the temperature by 55.5 degrees Celsius. So that's going to go in for delta T. Once I plug that into my calculator, I get that that was 6,229 joules of energy. Here's another example. What is the identity of a metal if a 95.4 gram sample absorbs 827 joules of heat, causing it to change from 25.5 degrees Celsius to 48.0 degrees Celsius? Again, we've only learned one formula so far, and that is our Q equals mc delta T, but we do see that we have a change in temperature, and that's what's going to tell us eventually that this is the formula that we need to use. When we have a change in temperature, this is the only formula we're going to learn that has that change in temperature. So now we'll start plugging in. Q is heat. We see that our heat is 827 joules, so we can plug that in. We see that our mass is 95.4 grams. In this case, in order to identify our metal, we're going to solve for the specific heat. So I'm going to put an X there. And then for our change in temperature, remember we always do final minus initial. So our final temperature was 48 degrees Celsius. My initial temperature was 25.5. Solving that for X, I get 0.385 joules per gram degree Celsius as my specific heat. Now, in order to identify our metal, we're going to go back to that chart on our yellow sheet. We're going to find 0.385, and we see that that is going to be copper. Now, when we think about phase changes, what you'll notice in our heating curve later on is that the temperature at a phase change doesn't change. Whenever it is melting, it is consistently staying 0 degrees Celsius. Whenever it is vaporizing, it is consistently staying 100 degrees Celsius. And of course, I'm talking about water. That's the only phase change that we're going to worry about dealing with these HF and HV values is water. So because at the phase change, the temperature does not change, we can't use Q equals mc delta T to calculate the heat needed in order to do that. So we have two different formulas that we use for these phase changes. We have Q equals MHF and Q equals MHV. HF is the heat needed to melt 1 mole of a given solid, and HV is the heat needed to vaporize 1 mole of a given liquid. And so again, the only values we're going to worry about are those for water, and those are given on page 1 of your reference table. Here we see that HF for water is 334, HV for water is 2,260. Also in there, you'll see the specific heat of water. So when you're dealing with temperature changes with water, you'll have different values for different phases of water. So you need to pay attention to that when you're doing these type of problems. All right, so let's just do a quick little summary of our 3 heat formulas and when to use them. So the first one we learned was Q equals MC delta T. You're going to use this heat formula when you have a change in temperature. So if your question says anything about changing the temperature, then that's the formula that you're going to use. If you don't see a change in temperature, then you want to start looking for some keywords. If you see the keywords melt, freeze, or ice, that's going to tell you to use Q equals MHF. If you see the keywords vaporize, condense, or steam, that's going to tell you to use the formula Q equals MHV. So make sure that you write this down so that you can look back at that later on. So let's take a look at our next example. So this one says, how much heat is absorbed when 24.8 grams of water at 100 degrees Celsius and 101.3 kilopascals is converted to steam at 100 degrees Celsius? So the first thing we want to ask ourselves is there a change in temperature? Well, we see that it's at 100 degrees and it's staying at 100 degrees. So there is no change in temperature this time, which means we cannot use MC delta T. So now we need to look for some keywords. And so I see the keyword right here of steam. And so steam was a keyword for us to use Q equals MHV. Now let's plug in. Okay, again, Q is heat. That's what we're looking for. M is mass, which is 24.8 grams. Now I need to figure out what is the value of HV. So I'm going to look on the front page of my reference table, and I see that HV is 2,260 joules per gram. So I will plug that in as well. Multiplying those two together, we find out that our heat is 56,048 joules in order to convert that to steam. Let's do one more example. This one says, how many grams of ice at 0 degrees Celsius will melt if 2.25 kilojoules of heat are added? Okay, so again, we want to first figure out, is there a change in temperature? But we see that we only have the one temperature here, 0 degrees. It's not changing, so we cannot use MC delta T. Now we need to look for some keywords. So we see ice, we see melt. Those were both keywords for Q equals MHF. Now when we are dealing with heat, our heat that we plug into this formula has to be in joules, not kilojoules. So the first thing that we want to do is want to convert those kilojoules. So 2.25 kilojoules, for every 1 kilojoule, there are 1,000 joules. So that's going to give me a value of 2,250 joules. In this case, we are looking for the mass, so that's going to be my X. Now we need to find the value for HF. Again, going to the front page of our reference table, we see HF is 334, so we'll plug that in right there. So when we divide that, we get that we would have 6.74 grams of ice.